right, let's figure this out. Brad's gonna put his thing together. Maybe we'll look at some beetle wings. I got this bag full of beetle wings.
Okay, so that's Grubenikov, right? That's the Grubenikov experiment.
Yeah. Exhibition. We're gonna try running some voltages through them and see what we can come up with.
I got something to share. Hello?
Wish we could figure out a way to.
Was that you, Wayne?
Yeah.
Hey, Wayne, do you have a presentation that's set up?
I'm developing a presentation. Yeah.
Can you turn your phone on its, so it's upright facing, and then flip it back so it'll reorient your video.
Can you see that?
Log into Zoom. You got to tilt your camera. You got to tilt your phone to one orientation, then you got to flip it again so it'll correct it. So when you flip it again, it should automatically correct it. Give it a second. Well, I guess your phone. Oh well, that's okay. It's sideways, but yeah, for us it's sideways. For you, it's fine. Yeah, that's correct.
Okay.
Yeah.
So I just ran this one here. I've been looking at weight changes in metals, and I've been doing a whole bunch of experiments and tests on this. And I've been seeing these patterns of, as you can see on the graph here, this is over the course of about 170 minutes. And so from this point to this point here, there is a gain of about 6 milligrams. And then when I took the test sample, which is just this little cup of copper filings and a magnet, when I took it off the balance underneath, there was a bit of a drift, which was saying 3.4 milligrams. So according to this, the change in mass was about double what the scale drift was. And I remember you were saying before, Jeremiah, we need to test to see if the readings go back to zero, right? Once we remove the sample.
Before and after, you start with the sample, you start with the sample added, then you remove the sample at the end of the test and measure what your actual zero is. So,
and that's what I just did now, but this has been running for about 170 minutes. Yeah, I got to do more tests like this, but according to this, if it was just drift for whatever, see, this is what we haven't figured out with these laboratory, these balances, is that there seems to be a bit of a drift sometimes, and it's hard to explain, at least at this point, we don't know why. But in this case, it demonstrates that there's something else going on besides that. So, yeah.
I have some of my data too. You took that video sample and you made some data out of it. Feel free to show that if you want.
Yeah, I've done a whole bunch of these tests, and I've been seeing this with always with the copper filings, and other things weren't quite as responsive like that. And I did, interesting stuff. But I thought I'd just share that. I'm going to be putting this together pretty soon in a presentation. Once I solidify all this and make sure this data is really, not just due to some measurement error, but it looks.
Well, if it is due to error, rest assured we'll get down to the bottom of it and find out exactly where the error is coming from. So.
Yeah, you might want to I don't know if you want to comment on what you found with because you were replicating some of this stuff too.
Yeah, so far, I mean, it's been incredibly small changes, and they seem to be more related with the drift. So that extra null test at the end, obviously, I don't want to touch the sample during the entirety of the test, but during that test at the end, when I remove the sample and just measure the tear weight, I found that drift usually matches the changes so far.
Yeah. Yeah, this is the first time I've actually been looking for comparing the drift to what all the readings are saying here. So, and so far it seems to be confirming that there is a bit of a mass change going on there.
Well, that's really good news. Yeah, keep looking. My copper powder, either it's an alloy, it's not pure copper, or some other means, but for whatever reason, I was not able to replicate the results, and that's perfect.
Your data did show there was a tiny change, but it was small. Like I could see it on the graph here. I'll open it up here. I got it. Just give me a moment here. Think about where I put it. Just got to find the file here. Just give me a moment.
Gotta love that default icon though that you have set up. Gravity generators.
The what?
The gravity generators.
Oh yeah. Yeah, that's perfect. Yeah, it was around the Star Trek: The Next Generation. It's around the same time. I wonder if they got some ideas from Podkleinoff and his rotating superconductors or something like that.
Yeah, indeed. There's as Tim says, you know.
So this graph here shows the results of one of your tests. And if you do like a curve fitting line, you'd kind of make out that there was like a bit of a curve going on there, which looks like a little bit of a weight loss, and then a restoring to the original value over time. That's 60 minutes. But it was very small in your balance. Like
yeah, you can get the same kind of large scale results that you were looking at. It's almost a full order of magnitude off in one case at the best, and 2 orders of magnitude off in the worst case.
But I noticed there's always this pattern, like this. It's like a drop, and then a restoring back to the baseline value. So.
Yeah. Well, again, I've got to find a source for that cobalt oxide and that pure cobalt as well. I have not shopped eBay for it yet. But
yeah, I'm gonna be running that again. Just again, like with that, checking the comparing the drift versus the actual, what the data is saying over time there.
Yeah, and I have impure copper as well, and that could be part of the problem. It could be a copper alloy.
Yeah, it was just like copper from old plumbing, old copper pipes. So I don't know. Could be impurities, maybe.
Well, that's okay. If that's what you use, then that's what I'll use to replicate. I'll just file it down like you did.
Yeah.
Try to get the exact same type of sample and then do basically the same type of experiment. Only
could very well be a copper oxide, right?
So I can oxidize copper if need be. I mean, all I have to do is heat it up and give it a little bit of extra oxygen. So it oxidizes pretty fast. I can give it a fairly even coating if oxides are important.
Could be, yeah, because of the way they changes the, the electron, the way the electrons are shared in the atom and the molecules.
Yeah, I'm willing to try it. I have no problem filing down like a coupler or a piece of Schedule M pipe to try and get some suitable sample material if that's what needs to happen.
Sounds good.
Wow, no, that's looking pretty good on that very up close on the wing. Can we get a higher magnification on that, Jeremy? Yeah, get that focus. That was looking pretty darn good.
Yeah, I'm going up magnification right now, so we can go a little deeper on it.
I've been wanting to see the Electa that they sell on Amazon, Etsy, and eBay as well, because those brilliantly colored multispectral beetle wings are a common artifact, and I've never really seen a good up close microscopy on them. So this will be interesting if you can get a good focus. I do not remember how many times Grubenikov had to magnify. You could see that fine structured hair within the valley type of hexagonal geometry, but I don't see it initially here. Although it does look fairly structured.
Folks, I'm gonna have to bounce in a couple minutes. This was a great call and a great conference. I really enjoyed it. Congratulations to everybody that worked so hard and on putting everything together.
Thank you.
Yeah, with that, I'm gonna sign off, guys. Jeremiah, let's touch base, buddy.
Bye, Carl.
See you guys. See you, Brandon.
Oh, catch up, man. Always.
All right, Tim, best ever. Thank
Cheers.
you, man. Be well.
What's up? $43,600.
Are attempting to get the fine structure of the highest magnification in focus on the microscope for that up close on the beetle wing. Apparently having quite a bit of trouble getting the camera on the microscope to focus in on it.
Yeah, there's going to be any oscillation will get magnified a bunch. So.
Yeah, that's correct, Ed. The picture gravity structure. For those who are looking for the search term on what we're trying to see with the microscope right now, take a look at Grubenikov's original images that you can find online, and you'll see some of the fine structures that he photographed with his microscope back in the day. They're black and white photos. They show you some of the structures that he was seeing in association with the strange effects that he observed in laboratory experiments.
So what are you applying to these wings?
We're going to apply an ion drift across them from an electrode that emits ions to an electrode that collects them, have them block that space in between, and then oscillate them at a high frequency using either a speaker or a transducer, depending on how well structured they are to the framework that they're on and how well they actually pick up that oscillating field of air compressions. So I'm not sure exactly what frequency they will couple well with and how flexible they are what their elasticity is, so I'm not sure what they need to be driven with. But the general idea was to get a fairly high voltage asymmetrical charge on the surface of those things on the inside surface, and have that as compared to a ground plane behind it, and then oscillate them against that ground plane to cause very large fluctuations in the electric field due to the charges trapped on the surface of the wing. The Casimir forces that should be present there may be asymmetrical between the two sides due to the presence of the asymmetric charge and the geometric amplification of the accelerated charges that are trapped on that wing. Because technically there's going to be more electrons than protons, or more protons than electrons. So in that case, you have these unbalanced charges and you're accelerating them both to the same velocity. The difference in terms of the relativistic amplification of the electric fields should equal an unbalanced charge, is the general idea. But there's also a gravitational aspect to it as well that considers the local energy density. And so that's one of those things that we can't really quantify very well. There's no real calculations that we can do to figure out what a beetle wing is going to do when it's electrostatically charged ahead of time. So we figure just go straight to the experiment and see what we can observe.
So would it have to do with the cavitation of the wing itself?
Generally, we think about cavitation in terms of molecular cavitation in fluid dynamics or in aerodynamics, or gas dynamics. So in this case, it's not necessarily a cavitation effect that has to do with the fluid atmosphere that the creature is flying through, more of the unbalanced charge trapped within those fine structure regions of the wing, and their distribution not being symmetrical, if that makes any sense.
So if that's true, it shouldn't change when you turn the wing over?
That would be the idea. Yeah, you should be able, if you get a force in one direction, that's say a weight gain, you should be able to flip the whole entire assembly upside down and get away at loss.
Okay. So it's kind of like a gravitational shield then?
Now that is a very good question. Hey, it looks like Brian is ready. He's got his cam on. So if we can jump straight over to Brian, if you've got a presentation, we've been very much looking forward to the Pi X and your advanced.
Yeah, I didn't really build a presentation for this because it's so new. I finally got it running. It's not complete, obviously, but unfortunately, I do have to cover up some of the internal components until we decide that a group of us decide that we're going to present the internals to the world. So right for now, it's sitting on a workbench. I do have a crank on it, so I can crank it manually. The crank comes off for safety purposes, obviously. I do have a speed controller, and right now this is a 24-volt motor, and it runs at 300 RPMs at 24 volts. Unfortunately, that's nowhere near as much as I would like it to do. But for now, this is what we're experimenting with, and then we can replace the motor with something a little better later. So as you can see, it's kind of loud. Like I don't have it set up quite the way I want it to present weight loss, but the scales always go in the negative direction. I did get a solid half-pound lift out of it at one point, and it was very stable. Since then, I've had to make some adjustments because some internal components were bending and breaking. Right now, like I said, it's just not running fast enough. What I'm going to do is I'm going to use these loops here, and we're going to put up a balance beam, and that way there won't be any question no mechanical spring scales, no electronic scales, no interference in any way, shape, or form. I think that'll be the best way that we can prove one way or the other that this is doing what it's supposed to do. Eventually, the internals run at half speed of this right now. And this being 300 RPMs max, that's 150 RPMs inside. And we would like the inside to be running right around 1,000 RPMs. So it is going to be considerably faster, considerably noisier, and hopefully it'll work considerably better. I can get a little bit better look around it. I mean, like I said, I can't show the internals right now. We do have the motor, the speed controller. It is chain drive from both sides. And I can get a little closer. It's going to get loud. I'll get a little closer while it's running. I would have liked to have had a little bit better presentation for everybody. Right now, I'm literally in the midst of changing careers. I'm retiring from one job and moving on to another. And in the process, part of what I was doing with this was in a workshop area at my previous work. So I've got a new small shop set up here, more like a model shop than a lab. And hopefully within the next few weeks, maybe by the next APEC, I'll have something a little better to show everybody.
Hey man, we appreciate the sneak peek ahead of time. It's awesome to see it working. And if I just may ask a question, the force in the orientation that your camera is set up, the force is upwards, is that correct?
Yes, the force is upward right now.
Okay, you're gonna have to tilt that.
The original designs that I was given were inaccurate at best, because the gentleman that invented this originally wanted to keep some of it secret. But the way he had it built was to force upward. So that's where we started. We started with a model that forced upward, and then it's been a long, laborious, and extremely expensive project to try to fill in all the blanks. And we've scrapped a lot of pieces in the process.
Yeah, I've watched some of your older videos too, and kind of gone through and watched through the iterations that you've worked on, how many steps that you've gone to make this system more robust, stable, lower friction, less noise, less vibration. So from what I just seen now in the video, I mean, unfortunately the video cuts out the sound, so I can't really hear how much it's jittering.
It gets pretty loud. It's too loud to have a normal conversation right next to one another right now.
But what I can't tell is, how much it's really bumping around, but it looks a lot more stable than some of the other designs that you've had. So it looks like you've made significant progress on the totality of the structure and the way that thing works.
Right. So, well, with the other ones, we were maxing them out in the RPM range of right around, 200 RPMs was really pushing it. And the best results we got was 1 pulse per RPM or per revolution. This one works better the faster it runs. And it's also 2 pulses per revolution. And that's 2 pulses per revolution of the internal discs, not the motor. So we're definitely making progress. It's getting more stable. I think once we get it up to speed and put it inside a sound deadening housing, we'll have a nice stable running unit that produces some significant thrust.
That's awesome, man. And we really look forward to your future APEC presentation when you have everything put together and you're pretty confident in your demonstration.
Absolutely. I appreciate you guys having me on. I mean, this has really been awesome. This past year has been really really cool.
Absolutely agree with you. It's really been a heck of a group effort. The amount of energy that people have poured in their heart and their souls into this, I've just been nothing short of absolutely amazed and astounded at the whole entire thing.
Oh, absolutely. And to have so many people sharing information freely amongst one another, that's almost unheard of. I mean, this is great. This is absolutely amazing.
Yeah. Well, yeah, I'd like to thank you as too. Thank you very much for coming on. It is amazing to have you. So,
Ryan, do you use any mercury in your device? Have
No,
you
I
tried
do not.
putting mercury in it?
No,
So-
no mercury. The original unit was made out of aluminum. This one is made out of nothing but steel. There are no aluminum components in it. So the original one was well under the 50-pound mark. This one sits here at almost 200 pounds. So we've made it very robust as much as possible to do as much experimentation without damaging anything. You know, something comes apart inside this thing, all I want to do is replace internal components. I don't want to be replacing major external components. So that's where we're at with this. And no mercury, no liquids of any kind inside it. I think that's pretty much all I've got for right now.
okay.
I
So
love
what else? Now we have a couple of questions. We have raised hands. Brian,
Sure.
do you want me to do that? I mean, so we've
Sure.
had some good stuff.
Absolutely.
Let's do that. So let's go to Bernie first. Bernie, what you got? Okay, Bernie disappeared.
Why
Okay,
did he just laugh? Come on.
Phil, what you got, sir?
Hey, yeah, and nice to see you guys having a good party over there. So that's not a question. That's more. I just wanted to say that I've got my experiment too. I will test and I'll create a video and I'll share it with you. Obviously, if it works, but I'm pretty confident it's gonna work, and I'll let you guys know more in a few weeks. It's very simple and pretty confident. So let's see what happens.
Awesome.
We're all anxious to see it. I can speak for everybody there.
Yeah, thanks. And good luck on your end also.
Thank you very much.
Well, so does anybody else have an ad hoc presentation? Do we have any more demos this evening? Does anybody else have something they want to present?
Yeah, if you give me like 3 minutes.
Yeah, go for it. So yeah, I think this has been a pretty big day. You know, a year ago we started this, and I'm not even sure why we started it. Mark Sokol called me up. He said we did a live cast and we want somebody to moderate things. He described it to me, and the first thing I said was no way. And then he was persistent and he said, no, you got to do this. You got to do this. And he started to describe things to me, and I was like, okay, I can see where this would go, you know. And and one of the things that I've said the whole time, for me, has been I want to try and capture the innovation. I want to try and capture the interactions. I want to try and capture that legacy of achievement, you know. And I mean, APEC it's been free and open the entire time. And what we're really trying to do is pass that along. You know, the reason that we put everything up online is we're trying to create an archive so that the people who come after us can learn from the people who are working on it right now.
It's a beautiful
Awesome.
thing that you've been doing, Tim. And I highly recommend everybody check out the Discord and the what was the other one you set up today?
Yeah, those are all in the contact. In fact, since we're waiting on Jeremiah, let me share the screen
WhatsApp,
again.
yeah, WhatsApp. Those are great discussions boards that you've made.
Yeah, give me 2 seconds. Let me bring that back up. Okay, give me just a sec here. Okay, so again, I'm going to share the screen here. This is the new alt propulsion site. And I'll walk you guys through what I did. Some of it's big, some of it's not so big. So that's our main page. That hasn't changed. What has changed is all of the conference pages have been rebuilt to make them a little bit easier to read. They've got, again, they have videos with chapters in them instead of being separate clips. They have the speakers. They have a little bit better layout for the text. So that is good. And we still have, we've still got the links and stuff at the bottom. And then the contact page, and this is a big one. Talk with us on WhatsApp. So we've got APEC 24/7 theory and builders. And again, those are our WhatsApp channels. I think everybody's on those, but if you're not, hop on. I should mention that you can mute. It is possible to mute channels. If you get too much, you can mute it without turning it off. And that way you can come back and read stuff later. The other thing we have is, and this is thanks to Phil, we have the Alt Propulsion Tapatalk forum. So Mr. Philippe Bouchard found this for us and actually started it. And he is moderating it for us too. I think, Philippe, you're moderating this, right?
Yes, I'm filtering the messages right now.
Okay, yeah. So he's running it. I put some graphics on it, but he is running this thing. And again, it's awesome to see this grow. So we've got the Tapatalk forum. Obviously, we have the Zoom seminars, and then we have Reddit, Facebook, and Discord. And Jeremiah just mentioned Discord. Oops. So that's going to take me to an app, and you know what? If you click on it from there and you're already in the group, it doesn't hurt to accept the app. So there you go. So now we've got folders, theory, experiment. Oops, those are phone folders. So there's a lot going on here. We have a lot, and we're going to be adding more to all of this. Again, this one's a little young for, and I don't mean the forum. I mean, the software itself was designed for people in a younger age group than ours. So it takes getting used to, but. So yeah, I mean, that was what I had. Again, that's on our website. You go to altpropulsion.com, click on contact. You can join all of those. I believe Kishley did a survey, and he said that the survey results said that the forum was the best. And so that would be Philippe's, or Phil, if it's okay to call you Phil, that would be Phil's Tapatalk forum right there.
Yeah, it's simple to call me Phil, thanks.
Yeah. And then the other thing I should mention is Tapatalk also has a mobile app too. And that was one of the things that, remember, because we were talking about different forum software, and you found that one. And the first thing I did was I was like, is there a mobile app for this? And there is. So yeah, and I pay the cost for that. It's cheap. It's like $10 a month. So I just pay for that. And then that way you get all the features.
All right, well, I don't know if you want to pin this for just a couple of minutes. I'll just show these waveforms. And if anybody's familiar with the Morton effect thruster, I don't know, can you pin this, Tim, or no? This cell?
Yeah, actually, I just did pin it. It should be pinned.
Oh, doesn't look like it. Oh, there it is. Okay, boom, there it goes. Cool, awesome. So it's on remote trigger right now. Let me disconnect this source and reconnect this source. Turn this up to about 5.1 volts. Should work. All right. So I've got it on a remote trigger. This is a down here. This is a 48,000 volt power supply, 48,000 volt DC output positive power supply. It's got a diode chain isolator on it. There's a neon bulb indicator to show when power is flowing, and then that's going up through an elevator clip to these two transformers. There's 1 and 2. These are acting as isolators from the ground and from the power supply output, which is a multiplier in this case. And so if I hit the button here, this is just a remote cord. So what it's going to do is it's electrifying the output here cable. It's giving positive potential here to this back plate, negative potential to the rod here. And so electrons are going to oscillate in the rod as a result of the inductance of this inductor here and the capacitance between this plate and that plate, and then the capacitance of these two capacitors here, which are both ceramic high voltage capacitors. And so what we're looking at on the waveform of the scope here, we have a pickup probe. This is a spherical 2-quarter-inch diameter probe with a wire on it. The oscilloscope is hooked up to just a direct wire connection. I have a neon bulb on here for other experiments, which is not in the circuit right now. And so that probe then goes to the display there. So at the first part of the waveform here, as we've seen, there's a very, very fast rise time pulse. And if I zoom in on that, at just how fast that pulse actually is, that's a 10 nanosecond per division scale. So that's a rise time initially of 4 nanoseconds into the positive regime on that antenna rod. And then if we zoom way out, we can see our net. So now we're out at 2 microseconds per division. So for about 4 microseconds after that initial several nanosecond pulse, it stays positive for about 4 microseconds, and then it immediately cuts negative. And eventually goes back to ground. And it takes almost, as we can see, 2 milliseconds to go from its positive peak to an inversion of negative, where it stays for almost 2 milliseconds, several orders of magnitude longer than it stays positive. And so what we end up seeing is a case where we can shield some of this energy. So this is a scalar type impulse. It's been a hot word in the discussions lately. The word scalar is unfortunately terribly misdefined. And I'm not going to even attempt to challenge all of the various definitions right now. I will demonstrate this experiment, however. So there's a waveform on the scope. I'm going to zoom in on this so that we can see, hopefully we can see a little bit better. I guess I'll get closer to the scope. Okay, so we can see the peak of the waveform there. I'm going to stick this aluminum plate between the terminals here to block some of that signal here. So the aluminum plate does virtually nothing. It does slightly attenuate it by about maybe 15%. Now, if I ground that aluminum plate with a very short lead of wire from the plate down to the power supply, it does attenuate and block it. So I figured, why not try a dielectric? So here's a piece of dielectric, and just watch that scope waveform again. So it basically ignores the dielectric. It passes straight through that. It passes straight through the aluminum. I have put the pickup probe inside of a enclosed Faraday cage, and it passes right through that. Again, though, if I give it a source of electrons, they will flow up through that wire and neutralize out the charge a lot faster. So the waveforms will take a different shape. But as an example of what a scalar geometric pulse looks like on a scope and how different materials affect it, that's a practical example of that. I hope I didn't lose everybody on this demonstration.
No, you're good. You're good.
Because it's not really containing a lot of terms that I guess people can relate to. I apologize for that.
Well, thank you for the demo. Well, so if that's everything that you have, does anybody have questions about that? Okay, I think we're good on that for the time being. Okay, well, does anybody else have any other presentations? We might be getting to time to shut this thing down for the evening, I think.
I'm not ready right now, but if we could schedule something for an upcoming APEC, I would love to show some of.
Yeah. Again, let me know. Reach out and let me know, Bernie, and I will get that scheduled.
I emailed you now, Tim. You got to reply to me.
Oh, okay. I will, man. I haven't checked
We
my
got
inbox.
microwave-
I've been in this event all day long.
Right.
Yeah.
We'll make it happen for sure.
Okay. Well, I think it's probably time to call it a night then, guys. So happy first anniversary to APEC.
Woo! Yay! Good job.
How long till we get that set up, Brad?
Huh?
We're gonna miss it?
Well, I mean, if they shut off, they're gonna miss it. We're gonna.
Do you guys have something to demo? Okay, if you're gonna demo.
We're
Here,
trying to get this demo.
Great image.
I won't turn it off if you guys are working.
He's working hard trying to set this up for you guys. We get a live demo. I want to see this thing lose weight. We'll throw it on the scale, right?
That's right. That's what we're doing.
For the 26 people that are still here, Tim, I do have a full Zoom license, whatever. So you could throw me over the
Oh,
want to stick around.
okay. You mean make you the host?
Yeah, I'll stick around if anybody still wants to hang out and continue to chat.
Yeah, if you want to do that, I'm up
26
for it.
people left, so I can host it. If you got things to do, obviously you got a family and stuff. So
Yeah, definitely my end, Tim, because I'm streaming to both my YouTube as well as the Autodidactic channel right now. And in an hour, I got my buddy Mike with Faraday Research coming in, and beatboxer Ominous to do the science and sound stream that I'm just Your reach is even farther than you knew.
So I just wanted to share. I don't know if it's
No. I'm just trying to. I'm just looking at the.
There's a lot of noise in the background there. Can I just share one more little thing here?
Go for it.
Oh, okay.
Yeah. Well, I've got the video pinned on Mark. So.
Oh, okay.
Oh, you
Well,
wanted to show you.
If you're waiting for Mark, I was just going to share something that looks encouraging.
Here,
So
I'll add a pin there.
okay. Yeah, I was just waiting for my balance to reset back to 0 after I removed the sample, and it was following this curve here, so it was approaching 0, which tells me that the sample it appears that it did gain mass over that time. So, and it's on the order of a few milligrams, but it's something, and I think it's really interesting.
Yeah.
I'm going to be exploring this more, and hopefully I'll be able to put together a coherent presentation. And yeah,
Oh, thank you, sir.
You're welcome. My pleasure.
Okay. There we go. We'll go back to Mark. Mark is working on things. So Mark could, oh, actually that's not Mark, is it? No.
Yeah, we're here. I just muted it because we're getting some feedback and some noise and stuff. So
Yeah. So Jeremy, can you tell me what you're expecting to see again?
well, we got Brad setting up his machine right now, and we're going to be doing some sonic gravity tests with the scale right here. We're going to throw his apparatus on top of the scale and see if it loses weight as he claimed it was doing for him. So he's got
going to be even better. So we're going to lose more than 3.5 pounds.
more than 3.5 pounds
I
this
think
time.
so. So we got the graphene in there, so it's going to polarize the field. It's going to face all the kids the same way when we push them on the swing set. So that's going to be better. We're going to cut it. All right.
Cut the stream. Oh, you're going to cut. You're going to put your ear plugs on there. The saw's about to get going. All right. How much longer? You need my hand screwing screws in?
No, just we just gotta screw it together. We'll be in business.
Yeah, I just want to make this go quicker. We can show these guys on.
Well, yeah, I
APEC.
mean, they can wait if they want. It's gonna probably be like a half hour or so. Minimum.
Another half hour? Oh, we'll go to open discussion. then.
Well, not minimum. but-
Okay, you want to go to open discussion then?
Probably-
Yeah, definitely.
we go to
Okay.
commercial break or something. I mean. we got-
Well, Jeremiah,
live.
Jeremiah, do you want to take this over?
Yeah, man, send it on over to me. I'm gonna sit here and monitor.
Okay.
You can, I guess you can probably stop recording. We can do this more as a private discussion. I don't know if you want to, Jeremy, do you want to keep streaming?
Yeah, we're gonna keep streaming it, and we're gonna keep going. Brad's got another half hour or so.
Yeah,
until
and
he
I'll
gets-
I'll keep recording. I will keep recording, and I'll still be here. I'm gonna go get dinner started. So
Okay, yeah, man, no problem. I'll be in front of my computer for the most part here. So,
Yeah, there's still over 50 viewers on my stream with this as well right now.
yeah, that sounds good. Bernie, I'm going to highly recommend that you shut off that green screen background function because it looks like your camera's having a seizure. And unless you're intentionally trying to add distraction, it's probably not serving whatever you're presenting. So I would just recommend shutting that off entirely.
I'm
Yeah,
driving on this
background.
one. I will as soon as I get back to my house here.
Because yipes.
Guys, we're actually putting together a bridge rectifier for the power supply for this Klystron. So the auto transformer is now fixed. There was piles at the brushes and several other bits and pieces of metal that got in there, but it's working now. And this is going to be the bridge rectifier for the other side of the transformer. And we're putting capacitors in it for filtration as well. That's going to fit on top of our massive transformer over here, and that's where we can get 12,000 volts DC for the Osb experiments.
That's looking pretty good, Mark.
Yeah, it's coming together. This stuff is really heavy too. Just like lifting this stuff is a two-person job. That thing is like 100 pounds. These are the 20 kV 2 amp diodes. We're going to put them in parallel with the 50 kV 222 microfarad capacitors as filters. Two of them in parallel.
Yeah, that'll work very, very nicely. You will definitely have no problem powering your Klystrons with that, provided no short circuit happens.
Let's see, how's the badge going over there?
Jeremy's gonna have to unmute. And we gotta pin Jeremy. I do not have host control yet. Okay, let me see. Maybe I do have host control. Maybe not.
Hey, I'm here. What's up?
All right, cool. Sorry, I had no idea yet how that works. Awesome.
We're here.
Looks like you have interesting stuff going on your side of the cam. You're right over there with a badge and Brad, hey?
Yeah, so we're over here. Brad, how's the badge doing?
It is looking good. Almost got it totally.
You got it screwed down nice and tight?
Oh yeah. We gotta tighten up just a teeny bit. And then I'm gonna connect all the leads over here to the multimeter. And then we'll plug it in, and then we'll get that wood plate and we'll put it on top of there. And then, we'll be in business. So this is connected. I'm happy with that. How are we doing on friction? The biggest impediment to getting a failure to launch is the friction. So the friction between the plates and the spinner. Wish I could get that spinner a little bit higher.
Hey, Brad, was your upper rotating plate and that bottom stationary plate rubbing on each other in the first iteration?
Somebody said something.
Yeah, were those plates rubbing against each other, Brad?
What's that?
Were the plates rubbing against each other?
It's the spinner is flexible. And so what I've done here, you can see, is created these craft wire skis that it kind of goes around, because otherwise if I don't have that, then it flops kind of down and then it sits on the bottom here and it won't spin the way I want it to. You got to give it a little shove to get it going. That's not too bad. I mean, that might be okay. But when we got a failure to launch last time, was that it's just too much friction, it wouldn't start. And so I actually kind of whittled down all the contacts. I just chopped them all down. But then it only runs for a little bit because these wool contacts disintegrate pretty quick.
Yeah,
so,
those brushes.
Yeah, so, but my next iteration is I'm gonna make these contacts copper plate, like a ring, like a copper plate ring. And then I'll have these copper balls, these nubs that'll just sit on.
We're close.
So
this is something. This is an alien. Paul Murad pointed this connection out to me. This are two different crop circles that appeared over a couple different years. This one becomes really long, but this design with like the arcs is replicated down here. And then these are pulse widths and polarization encodings. And then you have something rotating. And so
It's trying to like knock that phase out of phase, right?
Yeah.
So you can skip that Higgs field.
yeah, and not everybody agrees with like what I think about
Right? You know,
the Higgs field and all that stuff, but that's the premise. That's kind of what I was going by when I came up with this. So if this
I love how
works,
you explain
I'll
it.
tend to corroborate.
what's that?
I love how he explains it with the 3 discs of time and like how he's measuring the dimensions of time, like breaking it down into the discs form.
You want to know what quantum gravity is? Quantum gravity is the force of the Higgs string, in my opinion. It's the force of the Higgs string jerking you into a different brain of time. And so if you think of mechanics of materials, if you're an engineer, there's something called the modulus elasticity. And so I think quantum gravity is time dilation times the modulus elasticity of the Higgs string. That's what I think it is. Because that's mass invariant, it's like mass independent. So it's all about, it's all about time dilation. And so if you think of like gravity, right? It's the gravitational constant times both the masses together divided by r squared. So I think it's the modulus elasticity times the time dilation divided by time squared. Because like if you accelerate really fast and you square a really small number of time, it's going to be like a lot of gravity, right? It's going to, if you accelerate really fast, but if you do it over a graduated period of time, same way as if your gravity is affecting over a long distance, then I think you get less gravitational force.
Right.
So I think that, anyway, we're not here to talk about that. So that's what I think. That's what I think. Quantum gravity. So yeah, so if you listen to my podcast, I kind of go through all that. And Yeah, so I think
So
I
it's
think
quantum
this kind of
gravity.
unifies quantum field theory and general relativity. And some people could disagree, and that's okay. But if you see any mass reduction on this, then it tends to corroborate that hypothesis.
How many segments do you have in that wheel? It looks an awful lot like Ed Leeds-Scallen's flywheel in its magnetic structure.
I have no idea what you're talking about. Though I only know when it comes to quantum physics, I only know that which it took me to think this up. So you're gonna have to explain to me what you're talking about. Because
What he was asking you is how many pads of graphene are on that thing, or how many dividing copper strips separate each pad of
24,
graphene?
25.
okay, the copper strips is 24, but that's not the important thing. The important thing is the relative spacing between the thickness of the magnets
24.
and the distance between the magnets. So because remember how I said I think matter is leashed to our time by the Higgs string, and it's a 4 Planck lengths orbit or 4 Planck diameter.
I took this.
You know, so what you need is 1, 2, 3, 4 out, just like you're pushing a kid on a swing. 1, 2, 3, 4 out, 1, 2, 3, 4 back. So it's 8 to 1 is the ratio. That's any rotational speed.
Yes. Oh my God. Yes. Your geometry is perfect.
Oh, thanks. Yeah. So I mean, so that's the thing. So these are like 3/8 inch magnets, and so they're 3 inches apart. So, so I mean that's deliberate. I mean that's important. I think if you want to come close to achieving a resonant frequency, a resonant sort of harmonic pulse.
So when are you gonna plug the vag in and get it working?
Yeah, pretty soon. I just need to screw the top on. I'll be in business.
Yeah.
Let's see, how many- So you got a screw over there for me? Ta-da. So, and then the last thing I have to do is hook up the load to the electrical system. I have to hook up that one too.
All right.
Whoa, wait a minute. So, shit, I almost forgot. I gotta move it. Hang on. Well, I'll do that in a minute.
What were you thinking? You gotta lube up your vag before you can get it.
Reduce that coefficient of friction.
That's right.
Reducing that coefficient of friction is key.
Ah, nuts. Brush to see how it's not touching.
If this does work, I would love it if the official name of this device is the badge.
Not touching enough.
It would
Right.
be great to learn about that in a textbook.
If I get
It's okay.
3
It's okay.
pounds of weight loss, I'll be excited.
Yeah, you can call it a badge and it'll be historic.
Yeah, it stands for Voorhees.
Well, Mark's got an unopened bottle of wine in the fridge for just such an occasion. Should something in the Falcon Space Lab actually lose weight and genuinely be provable, he's got that thing ready to pop the cap on.
Yeah, that's what I'm excited for. I hope it happens.
Heck yeah, absolutely.
Worst
Telling you,
case
it happens.
scenario,
Like
this
I've seen
podcast.
3.5 pounds go away. So I mean, we're doing it in front of you guys and everybody else with people here, so they don't like, oh, you're full of shit. It didn't happen, but it happened. I'm telling you. I mean, this thing, you know, those
No,
Tic
that's
Tacs
all
are
right.
zipping around massless, and
It
that's a
was right
fact.
over here.
So, and I think this is how they did it.
I wonder if the Tic Tacs are piloted by the tall whites. Who's in them?
Shoot, man, I don't know.
Well,
I
I'm
don't know
gonna
that,
tune into
but-
your podcast, man.
What's
It's a
that?
shame I haven't heard of you earlier, but I really
Yeah.
like hearing you speak about
I
this stuff.
appreciate that. Seriously, like, and since they came out,
For your podcast, actually, because I am also super intrigued and don't know why we have not heard of you before, Brian.
well, yeah, it's thoughtful, guys. I appreciate that. The It's Sonic and then hyphen, then gravity.com. Then when I started doing it, it's like a lot more stuff about leadership and, you know, all kinds of different stuff. And then, but then the Navy confirmed the, you know, that like UFOs existed. And then I have all kinds of mental illnesses, like I'm a psychopath technically, and well, I'm not ashamed of it, but I'm also like bipolar.
You're live, dude.
And when that's fine, I don't give a fuck. That's part of being
It's
psychopath.
part of my opinion as a West Coast person or from the Southwest, like the East.
Is that it? Are we all just mental? We're just suffering from
East
mental
Coast
illness
people
here
are
at
all
this
nuts. They make each other nuts.
No, as I've told Mark many times,
I was
Jeremy,
just like, I've
told Mark it takes a special kind of crazy. It takes the right kind of crazy,
The right kind
to
of
be wild
crazy.
enough to think that a human being could achieve the impossible according to our ordinary textbook physics.
Well, I mean, I was always a skeptic, like pretty hardcore until I saw the Navy Tic Tac footage, and then I was like, "Holy fuck!" My foot's
Yeah, I never
down.
even thought of
It has
it.
been
Better
for
footage
years.
of that? Haven't you just I hear? So is there
Okay, now
The evidence for something more is overwhelming at this
Would you
point.
mind bringing? Can you
Just
can the
Yeah, the
camera
Tic Tac
stretch?
footage is really a game changer.
All right, so
Like,
hey,
when it-
fellas, here you go.
Damn,
This
something's
is
going on.
so here's the. Oh,
Let's
where's
try
that
to
thing?
keep just one person at a
Oh,
time.
okay.
So, hey,
It's,
Jeremy,
that's
Jeremy's
okay.
phone.
So hey, so check this out. So the only way we get the electromagnetic field to fire up is if we have a current. And so all these leads, all the pluses are going to, all the pluses are going to this cathode here in this multimeter. Right here. Oh man, can somebody get me there's a claw, I'm missing a claw, it must have fallen off. It's always falling off.
An alligator clip.
Yeah, or if he's got a alligator clip on his multimeter on his positive, that's anyway. Okay, so we got so anyway, so here's all of the leads. Can you guys see?
Yeah.
So all of the leads. Remember, this is negative, 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 and then these four are positive. So the positive ones come here. The negative ones all tie right here. And so then we're going to be able to tell how much current, because then when this spins, it's going to, now the motors are plugged in, so that's what's cranking the motor. But when this thing spins, it's going to generate electricity, just like we talked about before, where this is like a battery. This is the minus, this is the minus, this is the plus. So come over to the multimeter. So what we're going to test first, we're going to go to resistance. So that's an open circuit. So here's the positive. So we should get something besides that, and we know we have a circuit. There you go. So there we go. You see how it's 0.05 ohms, 1 ohm, 500 milliohms for, okay, so we've got a circuit. So we know that if this spins, and if I can't reach it, but if I reached in there and gave it a little spin, you'd see we'd be generating some electricity. But when we run it, we're going to run it on milliamps. And so what that's going to do is that's going to tell us how many milliamps we're generating. And we are going to see some mass reduction between 8 and 15 milliamps, and that's a fact. So, did we find any alligator clip? No. I had one attached, and it must have fallen off somewhere through here.
And I have got to send Mark some alligator clips and Brett a tiny Titan circuit.
So hang on, fellas, we got to find a little Little piece of equipment. That's it. We'll be in business. You find it?
Something.
Oh yeah, that'll work. Okay.
Hey, they're asking here, is there any way we can get that camera on a tripod or some way to make it a little less shaky?
You don't like the Blair Witch Project?
I imagine not everybody can appreciate the, the random
You're artiste.
motions.
All right.
It's really fitting for an anti-gravity experiment to have the camera get a potato cam right before the experiment.
Okay, so if you're on any decent class starship, if your inertial dampeners are failing for like several minutes at a time, there's a serious problem, and you're going to have several major repairs on multiple decks. So you definitely want to try and suppress that as quickly as possible. And it's looking pretty good now, so it looks like they've got it back online.
Yeah.
That's got to do something just by looking at it.
We're in business.
Okay.
All right. Hey, I have a power strip, a black power strip with a bunch of.
Well, there's a power strip right there too.
All right.
What is that thing in the middle? Is that a record?
That's my boilerplate, man. That's sonic gravity.
What is that?
It's a boilerplate.
I don't know.
That's my podcast website, Sonic Gravity.
Okay,
He just means it's a piece of material with his logo on it.
gotcha.
Yeah, I mean, you got to know what you're looking at, you know, right?
How'd you make that? I get it.
Oh, I just, there's like some internet sign or whatever. They'll put it on plexiglass for you.
Oh yeah.
It's
Is it really blurry for you guys?
Hey, can
We're gonna have to do a camera change.
okay, hey, I'm gonna need like a paintbrush or something, because when you kickstart a electric motor, a brushless electric motor, you kind of got to give it a shove to kind of, because it has to get over that first magnet.
Get through the gates, yeah.
Yeah.
Are those a bunch of switching power supplies there?
Yeah. So the power supplies go to the
Each
motor.
coil in the motor.
Go to the coils in the motor. I think you can find this set up on like eBay
It's like
or
$100, yeah.
not eBay, the
Why?
Alibaba.
Why
Um,
so? Why
I think
so
I got
many
it
of
on
them? Though?
Amazon.
Oh,
Why so many of them?
it's for each sector of the motor.
Yeah, there's 8 coils in this motor.
Why can't you just run the 8 coils off one power supply?
I don't know.
Hey, Jeremy,
That's not
somebody
how-
who
I
live
didn't buy
streams
that
that
one, I
lost
guess. I
sound.
don't know.
Okay.
You could.
I mean, like when you build yours, like totally, dude. I mean, I built this thing by hand, so I was just sort of doing the best I could. You know what I mean?
I'm not being critical. I'm just trying to understand.
Yeah, no
What
reason.
I'm looking at.
No reason, dude. Like seriously, I think that's a good question. I just, the big thing, the thing that I was really going for was transparency. So it's transparent, right? Because I wanted to prove.
Yeah, but is it transparent aluminum?
No, it's not aluminum orthosilicate.
What? I don't even know what he's talking about.
It's a ceramic.
Star Trek 4, I guess. Yeah.
Oh no, I'm totally
it's
down.
real. Look up aluminum orthosilicate. That is transparent aluminum.
Okay, so I guess we'll have to put that on top.
Yeah. So we need to.
We'll have to move that camera
for a moment.
for a sec, yeah. And then it's a little bit, right? It's not like the center of mass or center of gravity. This thing is not right here. It's somewhere like over here. So when we,
Here, get the wood. Let's get that up. And then I hear what you're saying. I see the center of mass is over.
is that maybe like that?
Okay. Let's go out.
All right.
This way.
That's okay if that hangs off. I'm just gonna make it heavier.
Yeah.
All right, we there? Let me see. Hey, can you look at that transverse direction, see how we're doing? Like,
We're pretty good. No, what
Go this way?
Yeah.
all right, so kind of like half. I don't know, maybe a little bit more this way.
Okay.
That,
No, back, a little bit back. You went too far.
sure.
Yeah.
I don't know, man. I think that's pretty.
Well, we're trying, the center of mass, like Brad said, it's over here, all of the,
Yeah, I think. Yeah, we got to come this way.
oh gosh.
Hey, how you doing?
Are you sure?
Yeah,
Because it doesn't want to lean anyway.
because it's kind of leaning this way. We could see the level maybe.
It's rainy out there. Anybody want to go for a
Bring it
walk?
back towards the.
Yeah,
Yeah, you.
pretty good.
Yeah, it's good.
Yeah.
It's pretty
All right. So what we need, I need a paintbrush. I need something gentle on the tip. So when I turn this on, I can kind of give it a little push and we'll see how it does. But did you want to like set up your camera so you got one focused on down here? So we're at like 60, 61 and a quarter, 61, maybe 61 and 3/8. But like probably like a tripod pointing at this. And then if we could get one that was pointing at the multimeter so people could see the mass swing in tandem with the milliamp.
I don't have that many cameras. I can't do that.
Oh, okay.
I'm not gonna be able to do that.
All right, well,
unless
maybe we
get
just
all
set, like call it out.
We'll be able to go back and forth
Oh,
between
yeah,
them,
that's-
but I don't have that set up right
Okay,
now.
or you can just call it out.
I'm trying to test out cameras I bought a bunch of cameras to do this and I just tested them all out and they don't work. None of them work.
What about Mark's laptop?
We could get
Oh,
another
that's
laptop.
nice. I like how that
Oh,
works.
yeah, we could get another laptop.
Go get
watch
Mark's
it.
laptop and put it in here on the scale.
Where do you need another laptop?
I want another laptop in here
Where?
so they can.
Okay, so we would like a camera that's pointed straight at the face of the scale, and then a camera pointed at the face of the multimeter there, so we can so everybody can see what the
Can you see
amperage
that
we're putting
scale?
out is.
I can't see what I can see.
Here we go. No, that's not the one.
He's happy with this.
Is this on? Is it working?
It's connected now. Hold on.
Oh, okay.
Oh, here, I got my laptop on. Batteries instead.
If we get this thing spinning, it'll be business.
We'll be spinning.
Yeah.
All right.
Is it
I
working?
wonder if I can get that up in the StreamYard link. I don't know if I can. That's Brenda.
Well, there it is.
Yeah.
How do we zoom it? Can we zoom it?
Yeah. Can't zoom it.
Zoom what view?
This camera, can we zoom it in on that?
Just move the.
That's not the right.
Is it?
Would you rather have it focused on that?
Yeah, well, I mean, because you can't really, I mean, you could see sort of big swings in the needle, but
Like I said, I'm gonna have to go back and forth between them.
I mean, Brenda's laptop camera footage is actually really clear.
Is that okay?
that's pretty good. I'm happy with that. Or maybe can we scoot your in just a bit? I don't think we're gonna get more than 40 pounds.
Nice.
So it looks like right now we're at 61 and 3/4, 61 and 5/8 maybe.
What are you doing with my phone?
Hey, so can we get some ballast? Like some weight to put underneath of this? Because if this is,
You got from the lab.
the reason I want to put weight underneath of the spinner directly is because
We have lead weight.
I
in the
think
lab.
that's cool.
You-
I think the magnetic
lead weights,
field
Just get the whole thing.
really only, I want to say,
Ask for
exerts
Tim to throw
anti-gravity on the things that are in the field. So right now, the only thing in the field is like some of the
Not sure if Tim's
plastic
AFK.
and like the magnets and stuff. So I want to get some ballast underneath of the, I think we got some feedback. So I want to get some ballast that's directly underneath of the spinner so that we get like a more kind of sexy level of mass reduction. Because even if it drops the weight of the plastic and the magnets to zero, that's like, it's only going to be like a couple pounds, right? So
Yeah. You want it to drop the mass of something heavier?
yeah, I just want, because if we put more mass underneath of the disc, then it will be like more like drastic, right? I mean, that's the idea, right?
Can I move this or
No,
no?
oh, well, yeah, where do you need to put it?
I wanted to prop it up so maybe that it would capture on the camera.
That's a good idea, but it really can't move off of that. Is there like
Okay,
a,
that's
is there
fine.
like a stand that we could put the computer on that was right there that would kind of like point down on it?
No, but I can put a box or something.
Yeah, yeah. Thank you so much. That's helpful.
Oh, that's cool.
Okay, we got to be careful when you set on there because it's going to change the center of gravity.
We got the lead weight box.
Okay, awesome.
Basically, we're sticking lead weights. We're sticking lead weights inside the mass hole area, right?
That's exactly what we're doing. We put some weight here.
Asshole of the vag.
That's right.
Can I put your computer on this? Or no? Needs to go up higher yet. To try to get.
Oh, if you want to look down, go up higher. Get the box out of the way.
And the reason that I think this is like a good idea is because, so we had this failure launch when we first did it, we live streamed it and it wouldn't spin because there was too much friction. And so I got these screws and I was like doing surgery on it. And I left the screws right here. And that's when we got the massive way more mass reduction was because I think the screws were, that was the swing.
That was what was causing it?
Yeah, well, because the screws were heavier and they were right in the field. And so that's when you could see the swing. All right. Are we dialed in looking at the,
No, I don't think so.
oh, okay.
I don't, Mark, what is your camera looking at?
It's looking at everything. It's perfect.
Can it read this? That's what we're.
It
trying
can
to-
read it, it's just that it needs to be, it needs to be pinned. Tim Ventura needs to pin it. Tim, are you there?
I pinned it. I pinned it on.
I got you guys. I got you. I pinned it. Sorry. No, I just I wasn't sure whose
I
video that
think
was.
Tim is the only one who can actually pin it for the live
So
stream.
you
I
can
he
see
sent
them
it over to
multiple-
me. It's actually I'm supposed to be doing
No,
it.
for the
I'm just,
live stream, it's what
falling
what's
behind.
on
So
my
sorry guys.
screen.
I got the host right now for the time being. You know.
Okay, so,
Whatever.
There's a couple different views that you can get it from. Okay, let's just go.
Sure.
Yeah, I'm
All
just
right,
gonna
well, just
The
make
one
it
that's
something
showing
that-
on my laptop is the one that broadcasts live.
Is it
to
on
my YouTube
milliamps right
channel.
there?
Well, you want to.
Doesn't matter what Jeremiah shows or what he pins.
You gotta
What's
show the
what's
scale.
showing
Hey,
right
Mark,
now is the scale.
Can you get it to,
This is
can
what's
you get it to
showing.
bright? No,
Live
can you
stream.
get it to bright so that, you know what I mean? Like on
Oh.
the view and make sure it's twisted to milliamps. There you go. And then milliamps is what we need.
Milliamps.
Yeah, it should be.
Well, if it's milliamps, then you have to move the lead over.
No, you want that, I think the little
Millivolts?
ones. Yeah. And then go to milliamps, like right there. I think
Millivolts, you mean?
milliamps there. Okay. So, hey, just tell me, am I getting a reading real quick? Just tell me if I'm generating anything. Oh, man. Okay. Ready? Did I generate anything? You see?
Down.
I can't see because of the angle.
It looks like there's a generation to me.
Okay, go again. Nothing.
You don't see anything?
No.
Okay, try the put it on the other side maybe if that was right. Try put a no,
I
put
expect
no,
you to see like a voltage, if anything.
no amps. We want amps. So can you put the red one like you said on the other side and then we'll try it?
Yeah, that would be, that's the correct way to measure milliamps is with a short. Okay. Okay, go ahead now.
All right. Oh fuck! Did I just hear that?
No, I don't see anything.
Remember this side right here. You don't want to hit your camera, right? Get any?
Nope.
All right, well, let's turn it on. Turn it on and we'll see what happens.
Okay, this is a short right now, so would that be fine?
Why is it short?
Because that's what you need to do in order to measure milliamps. You gotta short it out, see how much current. you make.
Well, I don't know. The way I said it before, like, was the way it works.
Measure. You can't measure milliamps unless you have it.
Ready?
Okay, yeah, it's set up so we can see.
All right, so okay, go ahead and flip the switch on the main power.
This one here?
Mhm.
The motor is set.
Okay, turn it off, would you? All right, so here, I'm gonna unscrew it, and I'm just gonna chuck it with my hand. Do you have my screw gun? Yeah, thanks.
I think you need like a 1x1 dowel. Someone over here. Brad.
Yeah.
This might be, this might fit in there.
Yeah.
That might.
Yeah, I'm just afraid I'm gonna tear that copper foil with that hard wood edge. Here, I'm just gonna peel this top off.
Maybe we get like a pull start situation.
What I need is set up with a ripcord or something.
Yeah, like a
So,
like an engine start.
yeah. All right. All right.
Ready, powered up?
Yeah, powered up.
3, 2, 1, go. Too much friction.
All right, turn it off. We gotta cut down some of the.
Yeah, we gotta cut
We
down
gotta
some of
cut
the,
down some of that.
that
We got too much
copper.
friction.
There's way too much copper in those wads.
What's that?
There's too much copper in those wads. They're too thick, too much
Yeah,
friction.
yeah. Or maybe, let's see. You know what? I don't think I need to. I don't need to bolt these ones down. I don't need the bolts down on the far ones.
How about we take it off the scale so it's a little bit more stable? Take off the top, cut down the copper wad level and run it on the table, make sure that it turns and then put it back up on the scale, okay?
Well, the trouble with that is when you run it, it starts to shred everything. And so you really,
Oh, you don't have that much runtime before it falls
yeah.
apart.
Not ideal, but here,
The Vag doesn't have that much runtime.
it's a little bit,
That's terrible.
it's a little testy.
Jeremy, have you ever experienced that?
Before you guys run it too, like if you just spend a few seconds just letting the scale stabilize, because it is really wobbly. And it'd be nice to see like the
Yeah, I
zero
mean,
reading.
Well, we're not worried about the scale. We're worried about getting the
It'll-
thing started to turn because there's too much friction with the brushes. That's the issue.
So once
So
it gets to
don't worry about
speed,
the scale measurements until we actually have something moving. You're not gonna,
do you have a pair of needle nose pliers?
yeah, they're in the lab.
We'll have this in just a sec. Just give me a sec.
Guys, just another hour, right? One more hour.
Well, I mean, you don't want to miss.
An hour or two, maybe two.
Well, I guess it's going to be recorded for posterity, so we're really close. Really close.
Jeremy's YouTube has no sound. Can someone tell him that?
Thank you so
I'm
much.
gonna shut the stream down because I'm
No,
done with
Pinky
YouTube.
wants to play now. We should show that at least.
I'm done with the stream. I don't know what's going on with the sound. I'm done with this. I'm done with the audio. Video is off now too. Oh, great. Oh, nothing's working. I'm shutting it down.
Hey, Jeremy, thanks for hanging in there.
All right,
Bye.
well, love you guys. I'm still streaming over on my channel here and Autodidactic. Dan joined us in here. Mike's gonna join in right away, and we're gonna be doing some more experiments with the spark gaps, as well as some science of sound.
Are you going to you want to stream that? I don't know if the APEC crowd wants to see that or what.
Yeah, no, it's okay. Whenever you guys are done with the Zoom, I'll just keep going in my StreamYard, and no worries.
Yeah, pop a link to your
shutting
YouTube,
down your.
to your StreamYard into the chat if anybody wants to join that. And if
Yeah,
there are
I'll do that right
topics you're
now.
presenting.
Yeah, I don't know what's going on with this laptop. I need to throw in the trash apparently, and or I need to get a better setup going. I don't know, but everything I set up to try to do is broken now.
It has to do with the
Zoom
StreamYard interface.
No idea. No, it's
They're working
StreamYard. Okay,
They're
it's
working on it.
StreamYard, and
I've been
it's Zoom.
talking to the actual directors at StreamYard and the
Bye.
developers.
See you later, guys. Thanks for watching.
No, it's a side bush. It's the side ones. It's the side ones. Those are where most of the.
All right, now we're just Zoom, man. No more YouTube channel. No more live stream.
I'm still going to my channels.
Yeah, that's fine. You're still streaming on your channel, but I just am having way too much technical difficulties on my end trying to like do the live stream and then try to do
Fair enough.
all this stuff. It's just like
Too much.
The audio is like really confusing because a lot of people are on the same live stream from several.
yeah, we're on the
angles.
stream live stream from several angles. So anytime you turn the audio on, it gets all this feedback and everything starts going fucking haywire. It just, I want to pull my hair out. I need another beer. Like, this out.
Go get one, buddy. You earned it. You certainly showed up ahead of time and did the work.
Jeremy definitely earned it. Everything we can give him. He turned this place into a freaking mansion of anti-gravity research. Spick and span. Like,
Yeah, it's usually really nice, but it is.
this is another level. Okay, are we ready for another friction test?
Yeah, we're getting close. Hang on just 1 second.
Basically, if you guys can hear us, we're having issues with the friction. Too much friction, so it can't spin.
No audio, no audio, no audio. Shut the fuck up.
All right.
You owe Co $1.
You swear, Jeremy. All right. No, don't do it. Okay. Yeah, don't burn up. Coils.
Lily, you think it's gonna work?
Boy.
Yeah, I removed this address in the letter. I had my.
Oh, it's gonna work already.
She has her lucky lighter.
Yeah, worst case scenario is swamp gas.
Well, this is a swamp gas, making machine, right?
Exactly. Yeah.
All right, let's try that.
You ready?
Yeah, let's fire it
Go.
up. Come on, get that.
Well, that was a lot better.
All right, turn on. We gotta cut down these. Sorry, fellas.
We got way too much friction. Maybe we could change out the center motor for like something more powerful.
Oh yeah, dude. If you got a center motor that's more powerful, I'll take it.
Yeah, I mean the center motor you have is pretty nice looking, but it really isn't contributing that much.
Yeah, it doesn't have a lot of. It probably spins this at like 5 threads or something.
Yeah, I mean, let's see what kind of motors we have.
Then we're gonna have to kill the live stream. We gotta replace the motor. But it's just a friction thing, man. We kill the friction. We beat the friction thing, man. I tell you.
I'd like to show you guys what Vinny St. Vincent's been doing with his flywheel, and you'll probably find some similar things, Brett.
Go pick out motor. There's a box of big motors.
Actually, you know what I could do if I just. We gotta pull the whole thing apart though. If we gotta change the motor, so like we're done for the night. If that's what we're gonna do.
Well, the only other option, there's two more copper rag thingies on the far side that you haven't pulled in yet. Pull the far one out.
What?
That copper rag over there.
Which one do you think is?
It's the far one and that one, the ones that we haven't worked on yet.
Okay.
Just pull it out. The one at the very far end. You have to get.
Well,
over the other.
okay, just so you know, that's gonna mess with the symmetry of the field. because
Doesn't
we-
matter. We have to
Yes,
get
it does.
We
matter.
have to get it to spin first.
Well, you're not, tell you what. Tell you
It
what.
will spin without that.
Yeah, that's here, trust me. There, I got that one.
I'm talking about the far one.
What?
The one that's
This one's
over
not
the
even
edge.
touching. Look, I got it. I got it.
No, you didn't touch it yet.
No, it's like barely touching the wheel. It's fine. All right. Barely touching the wheel. You don't have to listen.
That's a lot of friction there.
Oh, look, it's on.
Yes,
Yeah, go ahead and pull it out a little bit.
that's what I was telling you.
Yeah, that's good.
This is a huge source of friction right here. You have very few watts to work with that motor. It's not a very powerful motor.
Yeah, okay.
Okay, let's try spinning it again.
Give me a sec. The reason is it makes a huge difference. The symmetry of current makes a huge difference in the electric field, in the electromagnetic field. A huge difference. Because if the current eddies all over the wheel, then you're not going to get any. That's.
Yeah, this is fine.
Let me see.
Lift it up, let's spin it and see what that is.
Let me see.
Does anybody make like copper bearings?
Yeah, in the next iteration, I'm gonna have copper bearings.
You're gonna have a better motor too, because this is like, this is bullshit. You have to like fight against friction because the motor isn't powerful enough.
Well, when you make these things by hand.
What type of motor are you guys using? Are you using like a DC pulse like magnet motor or?
Yes.
Yeah, it's something that he got from the Orient.
I just got it on Amazon, you know?
Yeah, well, what you came from the Amazon?
Yeah.
Built in the Orient, and
Have you seen
Well, I
Jerry
mean, too,
Warren's
like-
work?
This is just, yeah, it's kind of curiosity, right? Like, I think I could do it. So it's just me trying to do it. So I'm not like.
you're like Thomas the Train. I think I can. I think I can.
Well, I know I can. But there we go. Now we're in business.
You ready?
Yeah. I'm good.
We're in business, guys. Like,
All right, so if we cut the friction off, we'll be all set. Ready?
okay, 1, 2, 3. Oh, definitely rolled more than unusual amount of rolling.
Let's go. Okay, it's the bushes on the bottom.
It's officially way too much friction. We need a more powerful motor. Either eliminate the friction or
Tell you what. All right. We'll get a little there. All right, now try it.
you ready?
Hang on, wait a minute. And try this one. All right. let's try it.
This is live experiments here. How many people are watching now? Go. Oh, yeah,
Right
look,
now,
Over
let's
60
take a
live
look.
watching on my channel.
it's spinning faster now.
Yeah, on Jeremy's stream, we got 18 people in the chat still. We have 25 people on Zoom.
All right, dude. Yeah.
Jeremy's stream has officially ended, so between the two of those.
I'm still streaming to my channel. It's got 20, and then
You gotta turn it off.
Autodidactic that's got another 50 on his.
Is it hitting the top? Is it hitting the top? It's hitting the top. That's why.
Where?
Right over here. Hang on a second. We really.
Dude, I think we need a stronger motor.
Yeah, we definitely. The strong motor is definitely good. All right.
Ready?
Let's try that.
3, 2, 1, go.
Yeah.
Almost there.
Yeah,
almost.
it's gotta be though. It's gotta be on the bottom.
Yeah, it's a fight between friction, but you have a the motor like really doesn't have enough power.
Yeah.
It doesn't have much juice to it.
Hey, maybe turn it on. Should we just turn it on and see if we can build up a little bit in the coils there and then try?
Go for it. It's on.
Oh, get there. Yeah, I don't know.
More powerful motor, bro.
Yeah. I know. I mean, I got it. Like it worked for me once. I guess maybe I fucked the motor up or something, or maybe the motor's. Because you've seen it run. You've seen the blue video where it's going tick 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 tick. It's running.
Yeah, but even in that video, it's barely running. Like, I mean, you can get much more efficient motors in this fancy one that you got.
Well, I wanted it to all be.
You gotta look into Jared Morin's DC pulse motors. They're top notch magnet.
So this is like a high torque situation. We need like low RPM, high torque. How many watts does it put out and what's the RPM?
Yeah.
So for me to try to explain that right now, I cannot do it justice because the way it works in his pulse motor,
can you buy it on Amazon with Prime shipping?
So it's like
Bernard, can you buy it on Amazon with Prime shipping?
Yes.
Okay, send me the link.
Okay.
Thank you. We'll forward it to Brad and then we'll convene next when we get the correct part.
Yeah, I'm not stopping this. I'm figuring it out.
Oh man.
You need the plastic barrier on the top.
No, can you get them off the table, please? I prefer not.
She wants her Happy Meal.
Yeah, I know. Thanks.
Picky, come. Picky.
Yeah.
Free natural energy at gmail.com is his email. I'll post it in the private chat for you, and you can order his pulse motors directly from him. I'm also going to post his channel link for you guys to see.
We're still live?
I don't know. I don't know.
Oh, we're still on
Yeah,
APEC.
still
here.
live here, a couple of
Yeah,
rounds.
we're on.
We're still hanging out on APEC, guys. What's up? You guys wouldn't believe what this place looked like. Can I show you guys a video of what this place looked like when I first came?
Heck yeah, man.
I think we got some videos on.
I think
here.
I might believe it.
All these tables, none of them were painted, that all that gray color's new. This wall was really bad shape. I painted the whole thing. We painted this hallway, all the doors, the door, the back room, the break room. We painted that shelf there. And we redid all these tables. So Mark, I came here and Mark was trying to sand down OSB, which is like that particle board. It's this stuff that if I show you the underneath of the table, you can see it. For those of you who don't know what OSB is, you can look it up. This stuff, I think, you see that? See that plywood? Oh, it's like plywood made of that chunky wood stuff.
Yeah,
That's called OSB. And he was trying to sand that down and paint it, and they sanded it with a sander and made all kinds of dust, and then they still didn't get it flat. And so what I said, you know, you wasted all that labor and you still didn't get it right. The best thing you should have done is got hardboard, and which is like $12 for a 4 foot by 8 foot sheet. All right. So we were able to get 6 sheets of that and redo all the tables. We just painted that hardboard. It's kind of like MDF, if you know what MDF is, medium density fiberboard. And I have a piece of it over here. I'll show you guys what I'm talking about. So if you guys want to make a work table like this for really cheap, you can make a lab table just like this for probably about around $100. But this is what it's called. It's like about an 1/8 or 3/16 of an inch thick, and it's got this one side's like it's like knitted or fabric board or whatever. It's like a weaved MDF, and then the top part is like cardboard, and it's very sturdy, very good solid working surface for a lab. You know, it paints really nice. The paint does pretty good on it, and I want to just show you guys how durable it is. You know, you can drop tools and stuff on it without, no. Like, where's the damage? You know?
Yeah, man, that's definitely the stuff to use for workbenches.
It's really hard to damage. It's $12 just for a 4x8 sheet, bro. And then when you're done with it, like in 5 years, when you destroy it, you just throw it away and put a new one down.
Exactly.
So, and then we use this stuff. This is about $20 for a 12-foot piece, and it's in the flooring section. And it's just a piece of stair nosing, you know. You'll find it in all the trim pieces in the flooring aisle at Home Depot or Lowe's. But yeah, this stuff, $12 a sheet, you can't go wrong with that, and it's super durable. Just try to cut through it with a utility knife. I don't have my utility knife right here with me. I'll show you guys. Just try to cut through. Oh yeah, here's a utility knife right here. I just want to show you the durability of this stuff. So it's like, I mean, it's hard to cut through. I scored that as hard as I could with a utility knife, and I would have to cut it. I would have to do that probably about 20 to 30 times to get through really hard scratches with a utility blade before I puncture the surface. So I'll give you an idea, and it doesn't delaminate, it doesn't peel, which is nice. I don't know. I haven't
And just
really
be careful that thing doesn't fall over and break the laptop nearby.
Yeah, that laptop's just chilling right under it. I don't want to take it out of there until we're ready. Okay.
Yeah.
You know, we should have, that's like something we should have had, like the $40 web camera. I had this other setup the last time I was here, and I can't find any of those web cameras now. And the cameras that I got won't work. None of them work when I hook them up. So it's just like,
I have an abundance of cameras.
yeah, I need some help on a good camera system because we went and bought this HDMI switcher so that I could have multi-camera. So it's like a 4 camera switcher that I have that I can do multi-camera mode. And it has 4 HDMI inputs. So I need cameras that can work on an HDMI output. So I can plug them into this HDMI switcher. Or I need to find a different switcher that works on, because if I could get a switcher that would work on 4 USB cameras, maybe I'll just get like 4 really nice web cameras and do like a switcher like that.
Yeah, this one's a micro USB. It's super nice. And then I got the regular Logitech USBs that are pretty good.
Well, the thing is too, right? A lot of it, like what I was thinking, I could do the Stream Deck, so I could do a software switching with the Stream Deck because I have a Stream Deck as well. So
nice.
I don't know.
I gotta get next. And you really gotta add me, Jeremy, on your StreamYard into the team part of admin now, so I can help you.
I'm doing a lot of experimenting, and like Joe, I went and looked up what kind of cameras Joe Rogan uses, and then I asked Ian, hey, what kind of cameras do you got in the studio at Tim Pool's, podcast, and he told me, and so I got some scoop on that, but then I can't get them to output HDMI into my laptop for some reason. It just doesn't work with this capture card I bought. I think it might be this capture card, and I don't think. We overloaded this trying to do the switching through this single cam link because it has to change like the input level, like the mode or whatever for each camera. It has to resync.
I find the best way is because you have multiple laptops there right now, is just use like 1 camera per laptop and just mute a couple of laptops, but run single cameras, high def cameras from each laptop and pre-position them ahead of time.
This cam link thing, it's made by the same company that makes the Stream Deck, Elgato or whatever, but it just this thing burnt out and it was a waste of $100. So I don't know. I gotta figure something else out. What's the deal, Brad?
If we tempted just to take the top off. Let me just take the top off.
Yeah, we got safety glasses in the lab and everyone's in there, standing behind the safety of their computer. So I'm not afraid. The thing's made out of copper and graphene, it's not like it's.
Yeah, if anyone's getting vaporized as you guys, we're fine here.
Yeah, it'll vaporize us, but you guys would be cool,
I won't vaporize you. But I think
even if it exploded and even if you got that thing up to 10,000 RPMs for some reason and it just sprayed everywhere and sent copper and graphene shrapnel on it wouldn't be that big a deal. It's not like super.
It would still be a breakthrough if something happened.
I don't think we need the top magnet ring to create electricity. I think we can do it just with the bottom one. So
I think
let's take the top one off.
I think we're good. Even if the thing flies off or something happens to it, I'll
suck us into a vortex. We're all insured, right?
I'll put a piece of cardboard around those microscopes over there so that they don't get smashed with debris. But other than that, I'm all right. I feel like if you were in terrorist training school and you made your shrapnel bomb out of copper and graphene, they'd fire you.
Yeah, maybe.
They'd be like, "This is not doing enough damage."
Yeah, hey, can you give them snips?
Yeah, if it flies off the scale, we're pretty awesome.
I'm trying to make jokes.
No, they're really funny. I just not very much. Let's see. And cut that one. Then what we'll do is we'll just take this bad boy. I don't know what that is.
The Wilmshirts device. When people blowing that up in the chat room in the live chat saying this is very half of a Wilmshirts device.
Yeah. So it's two plates. One has copper and one has aluminum, so they're dissimilar and they spin in different ways,
Really?
different directions.
That's not
So
what this
then
is,
it
but
creates. Um,
Yeah, that's similar to how the
electrons.
maglev works, right? And the
I don't
maglev
know.
train, the track on the maglev train, because it's just with the way that the monorail maglevs is like, it's just a spinning aluminum disc, and then it's like copper magnets. So
let's see if we get some. see if
and
we
then
get
somehow
some-
that does
Yeah, see where-
provides enough lift to lift the train.
Look at there. So where's our future? There.
I have a Wilmshirts Device at home.
Oh, yeah?
Did you make it?
No, somebody else did, and they gave it to me as a present.
I don't understand why it's not going. That should be like more than enough.
Sometimes it takes a little bit to build up the electrons. I found with my Wilmshirts Device. Like you just gotta keep spinning it, and the charge just builds.
Yeah, I mean, but like, this isn't the first time I did it. And it went way faster than this. Like this, it should be cooking. I don't understand why it's not going. The motors must be, maybe it's burned out. I don't know. Should go. If that's crazy, that it won't go.
There. I got that thing covered.
It's not going. Is it making any milliamps?
No, I don't see nothing, man.
There's one milliamp. Come on. The motor's weak. I don't understand how many we got more than 1 milliamp.
Yeah, someone in the comments said, what if you remove the disc from the motor and just test the motor?
Say again?
Remove the disc from the motor and test the motor.
Test the motor, yeah.
Yeah, no, it's kind of pain in the ass to remove the disc from the motor, but yeah. I mean, the motor. I mean, it's given a little bit because like when I go with that. Yeah, my motor's just trashed. That's it. That's the
Why is
motor.
it not spinning?
What's the weight on it right now? So it's 56 and an 8. 56 and an 8. So let's just see. Yeah. See if when it spins, if it does anything. See if we get any million. I don't know, they go 55 and 7/8. It's hard to say.
You want to live stream for $4 last round?
Yeah, I don't know. It's
2 hours.
not working. So
Really?
we're at 50 cent, 54 and 7/8, or 55 and 7/8. I don't know.
Yeah, human device. I don't know. You want me to ask them for what do y'all have?
You know, it's kind of going, but.
Hey, that was something, yeah.
Yeah. I don't know, we just need a new motor, I guess. All right, well, sorry, fellas, sorry, buddy.
Before you go, let me show a video of something with the exact.
No, it's just the motor's busted. I need a new motor to make it spin. But when we get a motor to make it spin, then we'll give you a show.
That'd be
Sorry
awesome.
Sorry we couldn't launch this time.
It's all right, man. This is still really entertaining. Appreciate the effort. And we'll
Yeah,
definitely
appreciate
be
that.
tuning in for the next show.
Yeah, but we'll definitely I just need a motor, man. I'll melt your face. I've actually got one. I just need a mount for it.
Can you guys see the video or?
Yeah, I've seen that one. That's actually it's a pretty faithful replication as far as somebody trying it at home. I mean,
Yeah,
there's
he's
not
been
very
building
many
it for over 10 years now. And this one, he's connecting giant quartz crystals into the levitating of the stone. through plywood.
Yeah.
I don't know if you've seen earlier, Bernie, but that video that I shared, that live demo that I shared, I used a piece of Herkimer as my spark gap discharge eradicator. So what spark will do is run over the surface of the quartz and it'll break the spark a lot faster than it would otherwise break in air.
Nice. Yeah, definitely on the same same wavelengths. Major breakthroughs are destined to happen.
So just
Well, I mean, you know, if you want high voltage exposed terminals and things like that, no, if you care about it and you're worried that somebody's gonna walk by and touch it or it's not properly controlled. Yeah, you know, certainly want to isolate your high voltage side from anything that would run.
Hey, do you have a motor that I can borrow to put in there?
Hey, Bernie, just so you know, it's your,
In the motor box.
for some reason, it's your other audio that's picking it up, like your microphone audio instead of
Yeah.
video.
Yeah.
But I mean, obviously, I don't want you to play a 20-minute video right now, but
I
just
stopped it. I posted
yeah,
it. I posted it in the chat instead. There we go.
Yeah, 1001. So. Jeremy, how you feeling? Ready to go home?
Yeah.
I'm like, I'm so beat. I've been up since. I've been up since yesterday.
Where's your motor box?
Check.
I don't even need to say how long I've been up for.
Yeah, if you guys want to install that motor tonight, I will tune in. If you want to do it tomorrow, I understand that too. Just let us know so we can tune in.
Yeah, we'll probably do another live stream tomorrow, like when we have something ready. It's just been like one technical.
Yeah, just shoot me a text, Mark.
We're fixing every single one of them as they come out. So it's just like.
Good morning, thanks.
Yeah, I mean, for this machine, he's got way too much resistance and nowhere near enough power to even spin the thing.
Mark, can I go on my
Yes.
Was it recording the whole time? I think so. I mean, I wasn't recording the whole time, but it's on. Thanks. See ya. Yeah.
Hey, guys, it's Tim. How are we
Hey,
doing on the,
Tim.
how are we doing on the
Tim, you can
conference?
probably kill the recording at this point.
You done? Okay.
No, never done.
I mean, well, I'll keep hosting the stream just for people that want to stay in the chat and communicate with each other. But we could probably kill the recording at this point.
Okay.
I don't think anything else, revolutionary is going to happen that needs to be on the record. So this will also offer people a chance to chat a little more freely.
Yeah. Well, happy.
Bernie, are you still streaming?
Oh, yeah, I'm still streaming to a couple of channels.
Maybe kill your chat too, Bernie.
Yeah, just to kind of give people that have stuck around a chance to chat a little more privately. Let's stop the live streams if there's any.
Well, I'll end the Zoom and I'm gonna keep streaming on my StreamYard. I got a bunch of people joining.
Well, there's some people that might want to chat, privately without the live stream going to the public.
Yeah.
Yeah,
Okay. Well, I'm
that's
gonna
what I'm
leave the conference then. It'll keep going, but I will
Bye,
start
Tim. Thank
compressing
you.
this. Hey, happy first anniversary, guys.
But
Thank you so much, Tim.
check out
And
the
then thank you
private
for
chat.
the year, man.
I posted
Tim.
the link for the
Have a good one,
DC
guys.
motor that